Hello everyone. If you remember, where we picked up in section 3.2 is what we're trying to achieve is we're trying to graph sine and cosine in this form. Now what we did in the last video is we just looked at what the letter A does to our sine and cosine function. Well, in this particular video, what we're going to do is we're going to study this letter B right here. So, first of all, if I give you y equals sine x, what is x? Well, x is the angle. Now, you know that y equals sine x has a period of 2 pi, okay? Has a period of 2 pi, which means the graph makes one complete cycle from 0 to 2 pi. That's one cycle, okay? One complete cycle. Now, what happens if we have y equals the sine of bx? Well, in order to complete one cycle, that means we need to figure out where bx equals 0 and where bx equals 2 pi. So essentially what we're saying here is that if we divide both of these sides by b, we know our cycle is from 0 to 2 pi over b. So this would be the intervals that describes one cycle of y equals sine bx. Now the same thing works for cosine as well. So, for instance, let's put this into a literal sense for you. We said that x equals 0 to 2 pi over b would be our interval. This would be one cycle. So it's going to be a little different than the normal sine graph. So for instance, if we have y equals the sine of 2x, well, b in this case is 2. b equals 2. So I know that my cycle is from 0, because I get that 0 from there, and I'm just writing it in interval notation here instead of x equals, okay? So how would we find the other endpoint? Well, that's 2 pi divided by 2, or 0 to pi. So what this means is that our interval, our cycle for a function of y equals 2x shrinks from 0 to 2 pi to 0 to pi. Okay, so this is shrinking our cycle. This is shrinking the size of one interval of our graph. Okay, this is shrinking the size of our period here. Is essentially what we're doing. It's shrinking the size of our period. Well, what happens if I give you this? What if I say the sine of x over 2? Well, if we say x over 2 equals 0 to x over 2 equals 2 pi. Well, the opposite of division is, of course, multiplication, so I'm going to multiply both sides by 2. So that gives me x equals 0 to x equals 4 when you do the 4 pi, when you do the same step on the right side there. So my period here is from 0 to 4 pi. Remember, this is our period. This is the new adjusted period because of our b, okay? So this is our period. This is what it takes, and basically what the period is. It's the interval that it takes to make one complete cycle of this graph. So now, this is not going to really change our y value. Our amplitude is still going to be 1 because the A value here is an understood 1, remember. So our amplitude's still going to be 1. Now, if you want to see what these graphs look like, all graphed together, it'll help make sense what this is actually doing to the period. If you look on your book, at the bottom of it, I can draw it, but it's going to be better for you to see it in your book. The bottom of page 141 in your book. If you look at that, okay, you're going to see the graph of y equals sine of 2x, y equals sine x, and y equals sine of x over 2. So if you notice, y equals sine 2x, it shrunk the period to 0 to pi. You see the normal y equals sine x, and y equals sine of x over 2 lengthened our period. It stretched it out to 4 pi. So you see what it does to the graph. It either scrunches it up, shrinks it up, or it stretches it out, okay, depending on whether it's growing our period or shrinking our period. Page 141 has an awesome depiction of that. Now, we'll do more with the actual graphing of it, and I'll show you the actual graphing of it here in just a moment, okay, when we do another example. So, this is it works the same way for cosine, okay. So, essentially, what we're doing, remember, is it's shrinking or stretching our graph horizontally, okay, by a factor of 1 over b, basically is what we're doing, okay. So, 2 pi over b, that's the key. This right here is the key thing for you to remember out of this, because when we get ready to start putting all this together and graphing one graph out of it, so far we know that A equals the amplitude. That's telling us if we're shrinking or growing our graph vertically. This tells us, our B tells us whether we're shrinking or growing our graph horizontally, okay? So that's the end of this video. We'll have another one here in just a moment.